And today she's going to present her findings on soil moisture assessment and drought conference in arid environment from uh, GNSS reflectometry. Sorry, I did not pronounce it well, maybe. This is exactly the topic, okay? So let's listen to her, learn something from her, okay? And feel free to ask questions. Thank you.
Okay, good afternoon, everyone. Some of you might know me, and some of you might have known me for the first time. I present myself for the second time. My name is Iladwini Sharafa. I'm Moroccan, and I'm a third year PhD student, majoring basically in trees integration and meteorological application in the remote sensing department. Today, I'll be explaining just some. I'll be giving you just a small view to my research and to my what I'm doing right now, and it's going to be focused on one of my articles, which is soil moisture and drought monitoring using GNSSR reflectometry. But most of the time, I'm going to be just saying GNSSR. And this one is going to be just like a comparative study between just a part of China, which is the eastern region, and a part of Africa, which is going to be basically the Horn of Africa. Okay. For the purpose of this study, I'm going to be following this outline. I'll be giving you just a small background on and I'll be defining some of the keywords just to let you understand what I'm talking about while I'm proceeding with my research. And then we're going to take a look at some of the previous research done in this topic. And I'm going to be giving you some articles that for those who are interested can take a look at, and we're going to take a look at what motivated me and why I'm choosing this topic. Second of all, we're going to take a look at the data and methodology. I'll be describing just my study area and taking a look at the data set and the resources that I took into consideration, and then the methodological approach that I took into consideration. We're going to see the results and analysis, we discuss it, and then we're going to finish with just a small conclusion. Feel free to ask if something is not understandable or not clear enough, and I hope you enjoyed the presentation. Well, it's all turn around the soil moisture. So basically, accurate soil moisture monitoring or data is so critical to understand the variation of water resources, and especially in arid region. Coming from an arid country myself, I do understand the impact that it may take on some countries, not only economically but on community as well. Well, though we have some traditional methods to assess soil moisture, it can be pretty costly, especially in Africa, and even the resolution is not that much. That's where remote sensing techniques come into the game to help us improve all of these and to help us uh, face these challenges. But for these techniques, for me, I'm going to choose the GNSSR, which offers accurate and efficient soil moisture monitoring. Okay. Now, to better understand the study, let's start just by defining two key words that's going to be repeated the whole time. The first one is drought. Can you tell me what comes to your mind when you hear drought? Most of the time, most of the people I heard, it's lack of precipitation, no water in the region, or something like that. And all of that is something natural. Maybe we as humans may contribute to that one way or another, but it's a natural hazard. It is characterized by a long duration, broad impact, and high frequency. Depending on the variable that we take into consideration, we can define three types that we're going to take a look at in the next slide. To monitor these droughts, we have two solutions. The first one is through a network of system of stations, which is basically in each country, there are like a system of stations that measures measures the soil moisture in specific fields. It is more reliable and more like effective, but the thing is that it is costly and only covers just a small area. And then we have the remote sensing techniques that covers a long and large, fast and large scale, and like give us so many information about so many drought characteristics. Now just as I mentioned before, we have three types of drought. The first one is the meteorological drought, which is like the most known ones. When you try to define drought, you define it by the lack of precipitation, which is the meteorological drought. Then we have the agricultural drought. Someone with, as an engineer, agronomy engineer, I have so many experience in this type, and this one is the most like, let's say that affects most of the African country because most of them are relying on the agriculture as like the main source of revenue, the main source of money that comes to that country. And basically, it is based on soil moisture, how it may affect the crops, and by like the end of the agricultural year, how it may reduce the yields. Then the last one, but not the least, is the hydrological drought. This one basically refers to the differences in surface and subsurface like water resources. All of these types of drought can have like some major impacts on the country, on the communities, on the environment, as well as the economy of certain countries. Now, the second keyword is GNFSR, which I'm gonna be like repeating each time. Basically, it's a remote sensing technique. It's like a technique that uses surface reflected GNSSR, which are these ones that you can see here. These reflected signals can act as a biostatic remote sensing radar that responds to changing surface conditions. Like it can detect the change from going to from land to sea to ice sea to the ocean and so on. And it can even like you can use it as well for the characterization of like soil roughness. Okay, then let's move. This GNSSR enhance like the soil moisture retrieval and can be used to overcome traditional method limitation. Studies like Harvard highlights that the need that we need basically different perspectives to when it comes to environmental monitoring and extreme climate detection. Okay, this as well aligns with the comprehensive and what we're gonna do in this investigation. Now that we just like give you a definition of the keywords, now we're gonna move to the previous article like that were done previously. Okay, these are some already like published articles that you may check. You can take a picture and you can like check these articles. Basically the first two are like just paper giving you a full review if you want to take a look at how we can use GNSSR in drought monitoring and soil moisture, giving you the status, the development, the opportunities, as well as the challenges that are faced in using these techniques. The second one is for those who are in computer science or AI. It's basically using machine learning and integrating it to the use of remote sensing, integrating both fields to create a more efficient and like cost-effective method to monitor drought and soil moisture variation. As for these two, these are like just basically case studies. Both are done in Africa. The first one is in Senegal, as well as for the second one is done in South Africa. You can check all of these articles that I've already shown. It's gonna give you a much broader and a much more detailed idea on this topic. Now that we just like take a brief previous progress on this topic, let's take a look at the challenges. There are so many, but for the main topic today, I'm going to be focusing on three. The first one is the measurements. When it comes to measuring soil moisture, Does any of you have any idea how we do like measure soil moisture on the field? Basically, you need like some sophisticated instruments. Maybe not as sophisticated because like in the lab of my last university we use some like basic methods. But the thing is that those basic methods may affect the results that you get at the end of the day. Then we have the complexity. When it comes to soil moisture, maybe I'm just talking about it, but anything in this world is interrelated. When it comes to soil moisture, we need to take so many other variables into consideration. You have the vegetation, you have the soil texture, you have the topography, you have the precipitation, the change of climate, as well as so many other things to take into consideration, which makes it way too complex to really give just a defined like value of soil moisture in a specific area, or a defined like drought monitoring technique in this area. Then we have the lack of data. This one is the biggest one, as basically, let's say you are like me, I'm from Morocco. Some organization may have access to data, but most of like, especially like students, do not have that. Or like agriculture, just like some like a normal person working on the field, you know that soil moisture affects his yield, affects his crops, and he needs some information. But since those organizations like have the data, he can't like get access to it. And then you have like, even if there is data, the data only cover like specific areas of the country, not the whole country, not the whole area of your study. Okay. Can you add any like challenges that you have faced when like looking at data for your study? There are so many challenges, but just these are some like examples. Now, for the motivation, I can say that the motivation stems from the need to address the limitations of traditional methods and so on. But to be honest, as someone who's coming from Africa, as an African myself, I know for certain that the drought or soil moisture variation affects our country so much that we need to like have a more involved and like understanding of these like phenomena. The objective basically for this study is to conduct a comparative study between Africa, which is like a continent, a whole continent, and China, which is only a country. Why they choose these two? Basically, African countries are mostly like the same when it comes to data and all of that, and especially when it comes to like drought. But for China, it's a developed country that focused a lot on these kind of remote sensing techniques and all in developing it. That they have so many studies that we can take into consideration to just like see how it helped them to develop so many strategies, so many management strategies for this specific phenomena. The second objective is to prove that it is beneficial for us to use GNSSR and integrate it with other remote sensing techniques. Okay, as you can see, just as I said, I have two continents, Africa, and you have over there like the China. In the African part, I only choose like the Horn of Africa. Some of you may be from one of these countries. It's this one like part. It involves Djibouti, Eritrea, Ethiopia, and Somalia. And for China, I only took the eastern part of China. Why did I take these two? Because both of these regions are susceptible to drought and water scarcity, making it like those recurring drought events in these areas underscore the critical need to really understand and make like some effective drought monitoring management strategies. I hope I'm not boring you. This is like taking so long, but it's okay. As for the data, for those who like are working on these kind of things, well, I have three sources of soil moisture. SciGNSS, which is basically GNSSR, and we have soil moisture SAR from SMAP Sentinel-1, and then we have SMAP, regular SMAP. Then I took into consideration TWI, which refers to Topographic Wetness Index, and then we have both of these are used, NDVI and SVI are used as drought indices. And the last two are like temperature and precipitation as meteorological data. Now let's take a look at the methodology. It's a basic methodology, not much to say. You first start with just the standardization of your whole data and taking it to 1 degree spatial resolution. Then the temporal alignment, as so many of the data came in daily data, and then we took it into converted it to monthly samples. Then we have the comparative analysis and basically this statistical validation and performance evaluation using either like Python or R language. Now, the most important part, which are the results. Now that we have, say, more or less a better understanding of like the methodology and the data we took into consideration, let's take a look at the results, starting with the evaluation and validation of Sentinel inside GNSS soil moisture. This part represents China and the Sentinel represents Africa. Well, these scatter plots are basically a comparison between GNSS and SAR against soil moisture data, which served as a reference in my case of study. You can find in other studies they take into consideration GLADIS as a reference. For the China region, we registered values. Oh, I think I gave like the wrong PPT. Anyway, for the China region, we registered values of 0.85 and 0.70 for SciGNSS and SAR respectively, and allow p-values of 0.02 and 0.04 that underscores the statistical significance of like these strong agreements between like the different sources of soil moisture. These findings were actually basically the same when it comes to Africa, though the values were a bit less, registering 0.75 for SciGNSS and 0.68. Now let's move on to, we did the same to TWI, which is Terrain Witness Index. The analysis here, as you can see from the graph, is inverted. We saw on the first one it was positive, but for this one is in like negative, and the values are less than the first one. They are weaker. If this were to say something, is that when it comes to terrain witness index, there are some variables and there are some factors that we need to consideration to better study and understand the situation over here. Now, this is a basic one. You can see this one every kind of study. This is just like a temporal this evolution of my variables. We have the three sources of soil moisture, and then we have SPI and DGAR and indices. We basically, and this one is the temporal evolution, and this one is the spatial distribution over here. Let's start with this temporal evolution here in Africa. As you can see, though there are some differences over here, like corresponding, especially when it comes to like summer duration, but it's basically the same evolution of most of the like the variables. The blue here represent the precipitation and variation of precipitation over here. From this, what can we say? We basically can say there is alignment between all of our variables here. Well, if we took a look at the spatial distribution, we can see that from that our soil moisture sources, especially SciGNSS and SAR, can detect can be like a useful tool to detect short period like drought. This is for Africa, but we can say the same when it comes to China. It's basically the same. And these close agreements between these different like soil moisture data sets and their alignment with the drought indicator demonstrate the reliability and the effectiveness of using and like integrating these indicators. Now, this is just basically like a heat map. I did it for both 2018 and 2019 just to see if there is like some discrepancies or some differences between the 2 years. But it's we can say it's basically the same. As in 2018, we registered. You can see here the values. If we take, for example, like side GNSS, and we compare it to SNAP or like other variables over here, we can see that side GNSS registered like a correlation value of 0.75 in 2018 and 0.74 in 2019. The temperature exhibits an inverse. It's not a positive, but like an inverse, especially when you compare it to like the temperature, the precipitation, which is natural, as the temperature is high, the value of soil moisture is low. This one is for Africa, but we can say the same in China, though the values are much different. Registering values of 0.5, 0.045 between 2018 and 2019. Though here we can see that NDVI showed like a consistent positive correlation with all soil moisture variables, site GNSS, SMAP, or SAR. Now, moving on to the discussion after seeing all of these results, what can we say? Well, we have, just like by taking a look at all of what we've seen already, we have a robust correlation and statistical significance against SMAP benchmark in Horn of Africa. This phrase basically means that when we compare our the data set from site GNSS and SAR that we gonna be integrating, we remark that it can be useful. It is like a good method to take into consideration. Then we have varying degrees of association in Africa and China, suggesting nuanced findings. Well, maybe like when we talked about soil moisture, yeah, it's the same. There are some positive correlation between all the sources, but there are some things to take into consideration is that the topography and so many other factors in China are so different than Africa. This is what we mean by nuanced findings. We have the strong global alignment in SAR and site GNSS. It's when we took a look at those temporal and the spatial distribution in both like countries, both like study areas A and B, like Africa and China. We saw like basically it's the same, and we have the alignment as well of all of these variables. This affirmed the accuracy of both SAR and site GNSS in monitoring drought conditions, which means that we can use these techniques to develop some and to suggest some strategies in the future for monitoring more like basically these extreme climate conditions. This consistent patterns and significant correlation in 2018 and 2019 can suggest not only that there is an influence of precipitation, temperature, and NDVI. When we talk about NDVI, we basically talk about vegetation and soil moisture dynamics. We can also say that these drought conditions prolonged for a long time in these two regions, especially in Africa. And if we say, if you take some of your time and took a look at those articles that I've mentioned before, you can see that the findings of my investigation, of my study, aligns with those previous studies. Like all of those findings, and these findings that we took from here can help you to enhance and comprehend the environmental process in the arid regions. integrating SAR, GNSSR, and LiDAR TWI, which is Terrain Witness Index, presents powerful approach for detecting soil moisture variation. And this remote sensing technique can present us with a high precision and temporal resolution or integrated approach, can facilitate effective drought monitoring and management strategies, particularly in region of arid and semi-arid countries. Okay. Last but not least, just a conclusion for all of what we said here. It's basically a repetition for all of what I was mentioning before. The study here provide us with a valuable insight when it comes to dynamics of drought, and you can use it not only for drought but for other extreme climate events such as floods, which will be my next research. This finding contributes to a deeper understanding when it comes to the environmental process and the water cycle and so on. And we have the integration of these methods can be useful in us in the future and can contribute to a more valuable understanding and to put on in place some drought monitoring and management strategies. Well, that brings us to the end of our presentation. It's my presentation. Thank you for your
think this is not enough. Please, let's appreciate her again, okay? We truly know that it's not easy at all. So now we are going to give 5 minutes for questions. If you have any questions, feel free to ask regarding the what you just presented. Don't ask something outside the box, okay? Regarding this. Anyone?
Hello.
Hi.
Actually, I want to know about accuracy of this GNSSR. I didn't hear about this before because I use meteorological stations data to do the same thing. I want to know the accuracy of this GNSSR. Hope you have some knowledge.
Well, when it comes to the accuracy, there are so many factors to take into consideration. What are you trying to what are you trying to measure? Because for me, I only focused on soil moisture retrieval, but when it comes to GNSSR, it's just one type of so many other remote sensing techniques. You have SMAP, you have so many other techniques to take into consideration. But when it comes to GNSSR, you can take into consideration surface roughness. You have so many other variables. But if I were to focus on soil moisture, I'm gonna tell you that accuracy is not as much as other variables, but taking into consideration that it covers basically the whole globe, it can cover that area. It's not as accurate as other techniques, but it's valuable when it comes to the coverage. Do you understand?
Yeah, I understand.
Yeah.
Yeah, I am working on drought index, historical drought means the previous any years was drought.
Yeah, the only one problem when it comes to drought, we always take into consideration so many years, but site genesis is a bit new. Yeah, it's only I think from 2017 till now, so it does not cover previous years, which you may need to integrate. Just as I said, you need to integrate other remote sensing techniques like SAR or SMAP or GLIDAS. Yeah, you're welcome.
It's interesting. Any questions again?
Thank you very much for your wonderful presentation and for sharing your experience.
Thank you.
I'm happy to see that. I have some few questions. In the introduction part, you mentioned three types of crop: zoological, agriculture, and hydrological crop. But under that, you indicated that both of them has a high impact on ecology.
Actually, all of them. All of them have like
I
this.
saw the presentation.
Yeah. Yeah, it was me, so it was my mistake. I sent the wrong presentation.
Okay.
All of like actually when it comes to drought, all of it's gonna have like some extreme impacts on our like on communities, on economics of countries and so on. Not only drought, but so many other like extreme events, even floods, which is the opposite of drought. It has some like not so good impacts on the country. Is that understandable?
Okay. Can I see the heat map,
Yeah, sure.
the first one?
The first one, this one.
Heat map. So when you compare different parameters, right? What is the
Yeah. This one
the
was I said.
difference?
I sent like the wrong PPT. But for like, I can give you like a link to my article. It have like the heat map with everything on it.
My final question is,
Yes, sure.
you were doing correlation between parameters, right?
Yeah.
And in your discussion, you indicated that climate changes climate parameters can affect soil moisture.
Let's say this. There are so many variables that can affect soil moisture.
Yeah, but
Just taking into consideration, if you were to measure soil moisture after like it rained, it's gonna be different from if you measure it in summer when it didn't rain, right? And then we have like the temperature. Once the temperature is so high, and then you take it to the field and measure the soil moisture of like a certain field, you're gonna see a big difference, right?
all of us we know that climate change and all climate parameters can affect others.
Yeah.
But how can you make it indicate that? Because correlation cannot just indicate association between two.
No, correlation is one.
Cannot indicate that which one affect the other.
No. For I said it and I've mentioned it. For the correlation, it was just like to prove that compared to SMAP, this is done in most in most studies. When you try to confirm that your like data can be used, you compare it to like an old like data set that's already used and proven to be effective. This is the same that I've done here. It was just to prove that it can be useful. And then after the correlation, we took a look at like the temporal variation and the like as well as the spatial distribution, not only the correlation. There are so many other parameters that were not shown here because this is just a presentation for, and it involves people who are not like who do not know the field that much as we do. Is that understandable? Yeah, I think.
Let's appreciate our asking for answering this question, okay? We have one more person to ask. If not, you still have one.
Hello?
You said that it have data from 2017 to now, right?
Yeah.
But if I remember that if we want to know, if we want to calculate indices for that, we must need more than around 30 years
Yeah.
the indices. So how can we calculate with such a low data?
This is what I'm saying. The data is new, but it is useful, it is effective, and that's the main reason. But we need like to make it useful for us to build an index. We need to integrate it with other old and useful, proven to be useful remote sensing techniques. For my case, I use SAR data, which is old, and like compared to GLADIS, which I didn't show here, and SMAP, it's proven to be useful for us. Okay. Because just for an example, SMAP, like data, it's like they said that it's not going to be useful in the future. So if you like mix it with this one that have like our future, like the future data and the old one, you can build your own index.
So have you done with comparison with that data of your
Yes, but for another region. Yeah, for another part. Yeah. Okay, that'll be it for my presentation. Thank you for your attention. Thank you.
Hello, can you hear me?
Sorry for the next presenter. You were actually not here, so we are going to you're going to join us online. But the two presenters, they're here. Okay.
Emmanuel, if you are here, you can like share the screen.
Okay, thank you very much. Am I audible? Can you hear me?
Yes,
Yeah, we can hear you.
Okay, let me just give me some few seconds to clear my screen. Okay, can you see my PPT?
Yeah, we can see your screen.
Oh, okay. As Aminu said, my apologies for not physically being present. I'm actually out of China for the project, so my apologies for that to the organizers and then done. All right. So my name is Emmanuel Yeboah from Ghana, specializing in 3S integration and meteorological applications. From the School of Moon Science and Geomatics Engineering, and my supervisor is Professor Goje Wang. And I'll be presenting on unraveling the causal impacts of energy balance components on urban heat island patterns in the mid-latitude region, focusing on Chongqing City as my study area. All right, so basically these are my contents. So I'll start with the introduction, which is basically followed by motivation of the study. And I'll transit to objective and move to the methodology results, policy implication, future focus, and of course, conclusion. So basically, this is just a build up on the previous paper I presented on during the AED conference. So to begin with, as most of you will agree with me, urbanization has led to unprecedented growth, posing both benefits and challenges to cities worldwide, which has basically led to energy consumption, environmental degradation, and alterations in the local climate patterns. And this, as a result, has produced a phenomenon which we call urban heat islands. So basically, urban heat island refers to elevated temperatures in urban areas as compared to rural or natural areas. So basically, there are a lot of factors which comes into play when you are looking at UHI. So factors such as land use, land cover change, which tends to alter the energy balance components of these our urban areas and has probably resulted in alterations and intensifications of the UHI. So as we all know, or as most of us know, UHI is expected to be more prominent in arid areas due to its geographical positioning. But there's a case whereby mid-latitude region are actually experiencing UHIs, which is unusual, so which piques our interest. So looking at Chongqing in particular, Chongqing is basically a mountainous areas. So as meteorologists or those in the meteorological field, we know that if you're in an elevated area, we are expected to have a cooler temperature. That is, if my memory serves me right. So the higher you go, the cooler it becomes. So most researchers have come out with that theory that indeed you have to be, if you are at a higher position, you are supposed to experience moderating temperatures. But here's the case, like Chongqing, which is a mountainous area, and looking at its geographical position in the mid-latitude region, is experiencing urban heat footprints. The question is, why is it experiencing these? It's basically because of changes, of course. So we have changes in our every day. We do some alterations in the landscape. From Chongqing in 1990s cannot be Chongqing in 2020. There has been changes. There has been expansion in terms of urbanization and the likes. So what we actually looking at is to see how these changes has caused this shift or has elevated temperatures in cities as compared to its rural counterparts. So basically, my objective is to first quantify how these various energy balance components. If I say energy balance component, for the purpose of those who are not familiar with energy balance, I'm talking about energy fluxes such as latent heat, ground heat, sensible heat, and of course, net radiation. Okay, so you're going to look at basically quantifying how changes in various energy balance components contribute to UHI intensification or reduction over time. So if I say over time, I mean from 1992 to 2022, which is a 30-year period. And then also introduce a new method. So basically, we're going to introduce a novel urban modeling, energy modeling approach that integrates the two source energy balance formula or model with the single layer urban canopy model. So if you say no, what that means is basically a new method that has not been used before. So this is the first time that we are going to integrate these two methods. And then we move on to proposing a 5-value centered leverage point that facilitates harnessing the values of nature to drive transformative change in Chongqing and other jurisdictions. So basically, it's just a policy system that basically helps to mitigate UHI, in other words. So basically, this is Chongqing as my study area. So we are looking at the left wing of Chongqing. That's where the city of Chongqing is hosted. So as I said earlier, it has a distinctive geological and cultural characteristics. In terms of geological, it's a mountainous area. So hence it earns its name, the mountainous region or the mountain region, due to its surrounding mountainous terrain. And as I said, it's also located in the subtropical climate region with a well-defined seasons. With the data, so we use a lot of data in here from both EC, MWF, and SERA data, where we obtained energy balance components data. So we are talking about long wave variation, short wave variation, humidity, and other stuff. And also, we also obtained 2-meter temperature data from our 5, which is also part of the ECMWF reanalysis data hub. Then we moved on to calculating these energy balance components. So as I said earlier, we calculated latent heat flux, sensible heat flux, ground heat flux, and then net radiation. Also, of course, we derived the single urban layer model by subtracting air temperature from land surface temperature. And then we extracted the results in the form of raster, vector, and tables. And we went on to calculate UHI, which is urban heat, where in this case, we are subtracting the temperature from the rural temperature, utilize the difference between the rural and others. And then we went on to do a correlation analysis, where Pearson's correlation analysis to be precise, where we looked at the relationship between each and every energy balance component with UHI, right? And then we, as I said, introduction of the new method which seeks to integrate.
Emmanuel, sorry for the distraction. Can you share your video, like your video, so people can?
Oh, okay, sure. Okay, let me just share the video.
It's okay, I think. It's okay if the network is not good.
All right. Oh, okay, sure. All right, so can I go ahead?
Ahead.
Okay. So it's my PPT. Can it be seen? Can you see my PPT, please?
Yes, we can see it.
All right. So moving on. So as I said, we introduced an integration method where we integrated the two source energy balance from model with the single layer urban canopy model. So in this case, we used what we call weighted averages. So basically those who are into energy balance, we see that the sensible heat is very, very related to the single layer urban canopy model. So we integrated the formula of the single urban layer canopy model to the sensible heat flux component of the two source energy balance component using weighted averages. So basically, this is because we want to ensure that both the two source energy balance component, which is basically governs the physical processes in the urban area, with the single layer urban canopy model, which allocates the contribution of vegetated and non-vegetated landforms. Okay, so basically integrating this basically ensures that both physical and urban canopy landforms are accurately accounted for in the analysis. Okay, so basically we went ahead to perform what we call geodetector analysis, which basically gives a spatial variations or spatial patterns across time. And then we went ahead to use k-means for the clustering analysis, which helps us to look at the concentration of UHI based on the existing urban canopy fluxes. Yeah, so we went ahead to perform what we call causality analysis. Let me just give a brief introduction about causality analysis in here. So causality analysis is more of a build-up on correlation. Yeah, so most of us use correlation, include the first presenter highlighted on correlation, and most of us use correlation. Correlation basically is very good, and it actually shows the relationship between variables. But the question is, correlation is asymmetric, and it does not give us the direction of influence, that's the magnitude and direction of influence. For instance, let's say UHI or temperature is related to built-up or urbanization. You have a value of, let's say, 0.76. The question is it that the influence is coming from built-up or the influence is coming from temperature? You can't tell, just say that the correlation is 0.6, from which to which. Okay, so causality comes to address these problems. And causality was introduced way back in the days, but it seems it has become more prominent, in which most of researchers have tapped into. Yeah, so in this case, you are going to use what we call a direct causality. Okay, you are going to this a direct causality, where direct causality means there are no confounding variables, there are no external forces acting on these variables. Okay, so in this case, you are going to look at causality in terms of spatial and temporal. Okay, it's more of a spatial temporal analysis. So you are going to utilize what we call the GCCM, that's the geographical convergence cross mapping, to assess spatial causal inference, and then the convergent cross mapping for temporal causal inference. Okay, just to look at the influence of these energy fluxes and UHI. Basically, there's a brief workflow that shows how the work was done. So basically, as I said earlier, you have the data sources on our left-hand side, and then we move on to the calculation of the energy balances or energy components, and then we derive the single layer urban canopy model, and then we extracted the results. We performed a correlation analysis. We integrated the results, that is using the TSV CLUM, using the weighted averages, of course. And then we went to look at the geodetector and glass rain to look at the spatial patterns across time. We calculated land surface temperature. We also derived the UHI via the land surface temperature by subtracting the rural areas from the urban areas. And then we went ahead to do causality analysis. As I said, causality analysis built up on correlation analysis. So we see that energy balance component is what's driving UHI in this context. So with the results, this is just a spatial distribution of energy balance fluxes across the Chongqing area. So we can see with the A in figure 1 is basically the latent heat. So you can see the latent heat is quite prominent at the outskirts of the city. That is because of the action of what evapotranspiration and evaporation from water bodies and vegetation. So as we all know, latent heat is fueled by these natural surfaces. As time goes on, you can see that latent heat is decreasing as a result of impervious surfaces being replaced, as a result of natural surfaces being replaced by impervious surfaces, which tends to reduce evaporation and evapotranspiration rates. I believe the first presenter also mentioned the water cycle. So basically, it is more of a water cycle mechanism or land-atmosphere interaction, where we can see that evaporation tends to cool the atmosphere and then condenses, then brings up rainfall. But here we are actually focusing on the condensation and then the cooling aspect. We're not moving into precipitation. But in contrast, sensible heat, ground heat, and net radiation tends to be more prominent from the city center as time goes on. That is because of the impervious surface and the kind of materials used in constructing the cities. Now, this has resulted in higher temperatures from the city center to suburban areas. So you can see that from the city center where there are a lot of impervious surfaces. If I say impervious, I mean built-ups, the urbanization or urbanized areas. You can see that the heat is mostly concentrated in the city center where built-up are more prominent. And as time goes on, it's spreading to the suburban and then the rural areas. That is because of expansion in urbanization. Cities are expanding worldwide, which I believe you agree with me. And we can see that maximum temperature, minimum temperature, and average temperature has increased, which has resulted in higher UHIs, as we can see from the color bands on our right-hand side. So integrating the two source energy balance with the single layer urban canopy model is the result that came out. So we can see that latent heat, as I said, is actually very, very prominent at the outskirts of the city, which is dominated by vegetation like forest, farmlands, grasslands, and of course, water bodies. But as you move closer to the city, it seems that it is quite very, very, very negative, as you can see there. In contrast, we can also see that sensible heat, ground heat, and of course, net radiation is quite prominent from the city centers and sub-city areas. So we can see it's evident that indeed these sensible heat, sensible heat, ground heat, and net radiation is absorbing latent heat in this case. Now, so we went ahead to conduct a correlation between these energy fluxes and UHI, and there are results. You can see that from the A, latent heat is quite have a more negative or inverse direction, inverse relation with UHI. That means because of these cooling effects from these vegetation, water bodies, and stuff. In contrast, it's evident that sensible heat, ground heat, and net radiation has a positive correlation with UHI. In this sense, you can see that there's no direction and there's no direction of influence. We don't know whether the influence is coming from UHI or is coming from these fluxes. Okay. So we went ahead to do what we call the geodetector or the geodetector and the glass strain analysis, where we use Q stats for the geodetector and K-means for the glass strain. And you can see that from table A, which is more of changes of latent heat to changes of UHI. You can see that latent heat is quite actually has influence on UHI at the outskirts of the city, where I said natural surfaces are more dominant. But as we move closer to the city, latent heat is quite, the influence of latent heat is very, very scanty or very, very small, which basically shows that indeed Chongqing has experienced significant change across the past 30 years as a result of, as I said, land use, land cover changes, which is fueled by urbanization. But in contrast, B, C, and D tells us a different story, whereby sensible heat becomes more prominent, as well as ground heat, and of course, net radiation. This is because of, as I said, expansion of impervious surfaces. Because if vegetation is present and you are clearing the land, we are clearing the land for build-up, of course, evapotranspiration will reduce, leaving the soil bare, even though there's a soil moisture content whereby which supports in evaporation. But since the land is bare, the cooling becomes very, very small. And on the right-hand side, which basically tells us the dominance of latent heat in A is reducing across time as a result of these changes. However, sensible heat, ground heat, and net radiation is expanding across time. So I just produced a statistical graph to show what's happening in these regions. So I divided these regions into 6 clusters. Okay, so the cluster 1 and cluster 2 is mostly dominated by latent heat, which is basically situated outside the city center. So you can see that the dominance of latent heat keeps decreasing across time. You can see that for the difference between 1992 and 2022 is quite vast. Because you can see that latent heat is even over 0.8 in 1992, but less than 0.8 in 2022. So basically, latent heat is quite dominant in cluster 1 and 2. Cluster 3 and 4 shows that latent heat is quite not that influential. The influencing variable here is much more net radiation, which is followed by sensible and then ground heat. But the main city center, which is cluster 5 and 6, shows that indeed there is a huge gap between latent heat and net radiation. That is because that is the city center. And of course, the kind of materials used tends towards trap heat, which basically leads to higher elevated temperatures in the city center. So we can see that latent heat is quite very small and tends to be smaller as time goes on. But net radiation, sensible heat, and then ground heat tends to increase or intensify as time goes on. Now, we move on to what happens when there is extreme hot and dry events. So basically, what we see on our screen, A, B, C, basically is what I did was that we extracted the results and then we used 10 years interval to represent 1 year. So basically 1992 to 2022, 2022 to, sorry, 1992 to 2002, 2002 to 2012, and then lastly, 2012 to 2022. So we have the 3 decades shown in here. So we can see that during extreme hot and dry events, both the red line represents daytime UHI, the orange or the yellow line represents average UHI, and then the green line represents nighttime UHI. With the bars, can I call it pink? The pink line the pink bar represents latent heat, which tends to decrease across time. The green line represents the green bar represents ground heat or the sensible heat. Yeah, sensible heat. And then the light or the sea blue represents ground heat, as well as the magenta or the violet line represents net radiation. So you can see that across the years, daytime UHI tends to amplify as a result of intensification of these fluxes. The negative intensification goes to the latent heat, and then the positive goes to ground heat, net radiation, and sensible heat. So, and also we can experience, we can also see that in the green line, which represents the nighttime UHI, tends to also amplify. That is because even the daytime, these building materials tends to trap the heat and then release as long wave radiation. Those interfluxes can also testify to this. So basically, during extreme heat, hot and dry season, or extreme hot and dry season, we UHI tends to what? Amplify. That means it tends to deviate from what? Its normal trend line. So, which is as a result of higher temperatures or elevated temperatures within the city center. Now, this is the results for the causality analysis. So this is the temporal causality inferences, which I said that this shows direction and what? And magnitude. So we can see from the diagram, you can see that the red dashes shows that the influence of what? UHI to the energy fluxes. So for instance, A, here, the red dashes means that UHI or urban heat island influencing latent heat. And then the blue line, which is latent heat influencing UHI. So the X mark may be the influence. That's basically the meaning. So you can see that there is a negative causation between UHI and latent heat. In this case, latent heat tends to influence UHI. Where there is latent heat, UHI tends to decrease. But in the other way around, UHI does not have any influence on latent heat. The availability or the presence of latent heat is not influenced by UHI. As I said, there is a direct causality and there are no confounding variables in this case. In contrast, sensible heat, ground heat, and nest radiation have a positive causal influence on UHI, where that means as impervious surfaces tends to expand or as urbanization tends to become more prominent, sensible heat becomes high, latent heat becomes high. Sensible heat becomes high, latent heat becomes low, ground heat becomes high, nest radiation becomes very high, and thereby influences UHI in the urban canopy. However, UHI, as I said earlier, does not have any direct causal relationship with this energy balance component. That is because UHI, the availability of the UHI does not influence the availability of these energy balance components. With the spatial, it is clear. So spatial basically gives a spatial impression of how these exchanges goes on in the spatial context. So the first A, which is latent heat, you can see that latent heat is quite prominent. It's influencing UHI at the outskirts of the city. But as you get closer to the city, latent heat becomes very, very small. That is because of the reduced evaporation and evapotranspiration rates in the city center. And then with the B, we basically represent the number of pixels that we pick. So as we go along as we head towards the city, you can see that if you pick 10 pixels, you can see that it's it's quite small. But as you pick 300 pixels of samples, it becomes very, very, very small. That is because we are heading towards the city and latent heat is decreasing. In contrast, we can see that both ground heat, sensible heat, and nest radiation has a positive causal influence on UHI, especially within the city center. But as you are going outskirts of the city center, the influence tends to reduce. That is because of the actions of what I said, latent heat or natural surfaces. Now, what's the way forward? What's the policy implication? What is this study proposing? So basically, this study is proposing ways of mitigating their UHIs. That is because excessive heat tends to bring some negative effects in terms of morbidity and mortality rates. Okay, excessive heat tends to is detrimental to human health and the environment as a whole. I say the environment, both plants and animals as well. So we looked at harnessing the values of these natural areas to drive the change in Chongqing. So first, we look at the diverse opportunities for the integration, where policy cycles in various geographical regions, particularly in cities, offer different opportunities for integrating valuation into decision-making processes. That is highlighting the need for innovative mechanisms to clarify urban transformation and sustainability efforts, which Pascal et al. Raised some time ago. So we proposed that we are going to use 5 points value-centered leverage points where basically aim to promote the sustainable development for the future by proposing various ways of mitigating UHI, both in the long term and short term. Okay, so this basically involves balancing values in decision making. With this, a holistic approach is necessary. That's recognizing both intrinsic and instrumental values in conserving policies. Okay, so policies like the tree planting policy, which we normally experience, especially the China government introduced this policy and tree planting just to regulate temperatures within the city center, which most of us or all of us know. So we move on to the need for the regulatory support. So basically the support not only relies on the government, it's also more of the whole, like both the citizen, both national and international, to at least buy into this idea just to curtail this harmful effects of elevated temperatures. If my memory serves me right. Now, so this is just a brief description of how the 5 value points is being designed, okay, for Chongqing. So it's more of a lever. So those who know a lever, it's just like a lever to. So first we look at the valuation, which more of acknowledging nature's diverse values, how nature is important to the society, and then you make a decision by integrating valuations in inclusive decision making, where purposefully and internationally include the diverse values of nature in decision making. We move to policy reforms, which embraces institutional efforts and stuff, and then societal safety and norms. Okay, most of our societies are being governed by norms and stuff. So basically, we mobilize these norms and then mobilize sustainability aligned values with the shapes and development of models. We look at the feedback direction, which basically expands the re-evaluation of existing values and then sustainability criteria and basically transform indicators. So basically, we move from the active evaluations to the prospective transformation change. So this basically involves looking at sponge cities, urban green areas, looking at urban blue. If I say blue, blue is more of a water body enhancement, which basically creates a more just and sustainable city for Chongqing. So we look at the narrow to the broad areas. So what will be the results of this policy? So basically, enhancing the evaluation framework will be part of it, and then incorporating the value, as I mentioned earlier, the 5-point value in decision making, and then also which basically leads to the reconfiguration of the city structures, whereby we can use more of green roofing and stuff, and then promoting new social norms. Culture, we say, dynamic. So basically, even though we are expanding the city, but it should be sustainably. It should not lead to excessive heat, which may cause increase in mortality rates, and of course, expand the re-evaluation existing values for these sustainable criteria. Now, with every study comes with limitation, right? So every study comes with limitation. So the limitation of this study is limited in terms of topology. And when I say topology, the study is limited representation of diverse urban topology in Chongqing. They understate, how should I use this word? The variability in UHI intensities, particularly by not fully capturing the complexity of mixed areas. So in this case, we are not looking at mixed areas where areas are both dominant with natural and impervious. We are looking at strictly impervious surfaces or built-up areas as compared to the mixed land use methods. And then we also did some omissions of mitigation strategies, whereby key UHI mitigation strategies such as green roofing and heat reflective materials were excluded from this study, potentially basically skewing interpretations of temperature distribution and underestimating the impact of these techniques on UHI patterns becomes quite crucial in this regard. So basically, what should future researchers look at? So there's a need for refinement of this classification or these studies, where future research may or should focus on incorporating more refined classifications of urban topologies and actively include mitigation factors to enhance the understanding of UHI dynamics across urban forms and climatic contexts. So as I said earlier, we can look at the mixed land use method. We can also look at climatic variables like soil precipitation, humidity, among the likes. And then also look at the broader context influence and behavior. So we actually exempted individual behaviors from this research. So highlighting the need for highlighting a comprehensive approach that considers social and environmental factors behaving or acting on these processes or UHI is very important in this regard. So wrapping up with the conclusion, cities worldwide face challenges posed by UHI, which is basically fueled by urbanization and its effects on these energy fluxes. So basically, our study focused on Chongqing, China, which explores the drivers and then the mitigating or adaptation strategies to mitigate this. So the key findings, it is evident that increase in ground heat, sensible heat, and net radiation tends to decrease latent heat over the past 3 decades or 30 years. That is because of artificial expansion or land use, land cover change. And we also tend to establish that there was a positive correlation and causation between UHI and sensible heat, ground heat, and the net radiation. In contrast, there was a negative causation and correlation with latent heat. So that is because as the land changes, various services tends to increase and then results in sensible heat, ground heat, and net radiation increase, which tends to amplify UHI. It becomes more prominent during extreme hot and dry events. So that is it, and these are my publication as well as co-authored publications. And thank you. If there are any questions or suggestions, I'll be happy to address it. Hello, can I be heard?
Yeah, we can hear you.
All right, so I had a question. All right, so this paper is currently under review at Sustainable Cities and Societies. For those of us who knows that journal, it's under review. It's just recently that they got some revisions for me to address. So it has not been published yet. It's under review at the moment. Yeah, but I'll be happy to share the content with you based on you not sharing with others because it has not been published yet. Yeah. I don't know whether I can be heard.
Yeah, we can hear you.
Yeah.
So any question again? Anyone? Okay, so we can look at the online questions. If there is anyone online who have questions, you can feel free to ask your question. But please turn on your speaker, please. Are you with us, the guys online? Emma, are you here with us?
Yeah, I'm here.
Someone asked questions online. I saying if the temperature difference between the rural and urban is 0.6 something, so what do you think? Can we say UHI is there? It is the first questions for online. I don't know where you get.
Okay, I've gotten it. So basically UHI is basically, as I said, is the temperature between urban and rural. So if the UHI is 0.6, that means temperature in urban areas is quite higher than temperatures in rural. So it's basically, yes, it means experiencing UHI. But the magnitude is not very, very significant, even though it's quite high, but it's not very, very significant. Yeah, so UHI is existing. That is because it's within the same area, but urban areas is experiencing more heat than rural areas, which is basically as a result of urban morphology, urbanization, and stuff. Yeah, so yes, UHR, the magnitude is not that significant. Thank you.
Okay, I hope Emmanuel answer your questions. Are you there with us, Ikra? If not, then we can ask the other one. The other one is saying why data from Era 5 is used for UHI calculations. Why not MODIS?
All right, so yeah, so okay, so MODIS, first of all, those who are into remote sensing, we know that MODIS started operating from 2000, right? Yeah, so, and this study is from 1990s, that's 1992 to 2022. And there are 5 has these kinds and this data archived for the past 30 years. So choosing MODIS means I have to narrow my years, which might be unfavorable to me because causality needs about 30 points or 30 years or more to establish causation. So the basic reason was because first, the MODIS was introduced in 2000s or late 1990s or 2000, if my memory serves me right. But you see, Era 5 has been there for the past, God knows who, for the past years, right? Yeah. And also, I didn't also use Landsat because you see, Landsat is 30 by 30 resolution. So basically, I can't use it, even though it's going to establish some, so you're going to give me some results, but the results will not be significant as compared to Era 5, which has 2-meter resolution. I don't know if I've answered the question.
Yeah, I believe you answered the questions. We have another question for you from Islam.
Hello, Emma. Good
Hello,
evening.
Antoine.
Yeah, well,
Good evening from your end.
so,
Yeah.
yeah, considering the location of the study area, yeah,
Okay.
yeah, you know that the study area is close to an industrialized area. So,
Okay.
don't you think that 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 other that's the surrounding city, don't you think that aerosols from other city can be can also add to the increase in the UHI over the Churchill reason?
Okay. Thank you very much for your question. That's a very good question. All right. So those who have been to Chongqing actually know that Chongqing is quite an isolated city due to its, as I said, geographical nature. It's quite monotonous. And as I said, we are looking at Chongqing city itself and its surrounding rural areas. So of course, other cities, other rural areas will be part of it. And the industrialization is mostly centered around the city. Okay. And then we also know that Chongqing, looking at, as I said, its mountainous nature, settling in Chongqing is quite, complicated. It's quite complicated. That is because you mentioned aerosols. Yeah, aerosols is actually more of an atmospheric phenomenon, right? Which basically tends to also influence it. So as I said earlier, we are looking at where there are no...
tidak berpartisipasi, nggak usah dikasih tahu.
I don't know if someone is interrupting. I don't know.
Yeah, go ahead. Go ahead.
Okay, so aerosol is more of an atmospheric phenomenon, and we basically expect aerosols to take action. But as I said, this research was done without any confounding variables, without any external force. So we are looking at a direct relationship, not an indirect relationship. So in our analysis, we tend to eliminate these kinds of external forces. Okay, so we tend to eliminate this kind of external forces in a way that in the code that we applied, we specifically removed external forces from it. I don't know whether your question has been answered as well.
You pretty answer. You pretty answer the questions. And we have one more questions. One more.
Hello, Emma.
Yeah, please go ahead.
Okay, thank you. Thank you again for your wonderful presentation. It is
You're welcome.
very good, and it shows your deep experience on research. And I hope most of us can learn from you. My question is about the causal analysis part, and
Okay.
you said that the energy balance components can affect urban heat island, while the UHI has no impacts on those energy uh, balance components.
Yeah,
Did
that's
you
correct.
did then have you done further analysis on this regard? Like, can we say has no uh, impact, or we can? It is better to say has no significant impact. We know that when urban island can cause heating effects and can also has impacts on environment. That was my question. Thank you.
Okay. Okay, thank you very much for that. That's a very brilliant question to ask. Yeah, so okay. All right, so let me put it this way. In a direct causality, I know most of you are not familiar with causality. So when you are conducting a causality analysis is a very tedious and very difficult analysis. I believe some of us, such as Matthew, have touched causality before. Faria, Rashenda, Jaffrey, Hasib, Vincent, and the rest, those who are in our lab have actually touched base on causality analysis. So in the case of a direct causality analysis, in the codes that we employ, be it GCCM, CCM, information flow, any other causality method that you use, the code has a very powerful ability to remove confounding variables. So as I said, there are no forces acting on them. This is strictly a direct whereby we are looking at the cause and then the effect. So there are no confounding. So the causal code is very powerful in such a way it's able to remove all confounding variables. And then in the case of UHI, it's not possible that UHI has effect on these energy balance components. That is because the energy balance component causes UHI. So this is how the mechanism goes. Temperature rises, right? And temperature tends to what? Influence these energy balance components. And in turn, the energy balance components influence UHI. There are no feedback loops in this case. That is because there is no way UHI, being the end product, have influence on the energy balance component. If it were to be so, that could take thousands of years to experience that if there's a feedback loop. That is why there's no significant influence. It's the end product. Okay, the end product. Take it as you drinking a bottle of water. When you drink it, it becomes what it finishes. There's no way it can reproduce itself. There's no way it can have a regenerative capacity. It is done. Okay, so that is how I can put it. So it's an end product of the energy balance influence, and there's no feedback loop. The only way there can be a feedback loop is when there's a confounding variable. That's when there's an external force acting on UHI to give a feedback to the energy balance fluxes or the energy balance component. I don't know whether it's quite technical, but I believe one way or the other answered your question.
This interesting and amazing for us. Can we appreciate Emmanuel for
Thank you very much.
I think with this, Emmanuel will say thank you very much for your effort, and we wish you safe trip as you are coming back.
Many thanks.
Yeah, thank you very much. So next, we feel like having 5-minute break. If you feel like you want 5-minute break, then after that we can listen to our next presenter. If not, then we can go ahead. What do you think? We continue because it's just In few 40 minutes, we will be finishing. We continue? Yes, okay, okay. Yeah. So now we are proceeding as suggested by many who set the PPT now, okay? So next, we are going to hear a presentation from Kamal. He's actually a hydrometeorology student, a PhD student, with years of experience in meteorology field, and of course hydrometeorology, focusing on greenhouse gases emissions and mitigation strategies. This is a very interesting area that everyone is working on now. So next to you. Let's welcome him, please. Global warming. Today I want to present paper that I published on greenhouse gas emission and mitigation on Africa, systematic review. Not working. Maybe here. Okay, my presentation has introduction, meteorology, result, and discussion, summary. At the end, recommendation. An introduction, climate change is one of case to lose biodiversity, water scarcity, agriculture, and health hazards. Also, in worldwide and in Africa, the greenhouse gas emission in Africa or in the world level is caused by two factors: human activity and nature. Human activities such as construction, deforestation, and in nature such as volcano and landslides are main factor of environmental disastration. And in average, the average of GDP in Africa by climate change and the world is nearby. So that is my interest to study on this area. As we see, the climate change has environmental degradation, also water resource scarcities, especially in Africa. Our women go for water finding in the minimum average of half hour and 1 hour, more than 1 hour to find and to filter water. Also in agricultural area, there is a lot of problems. The last figure shows that economical loss by global warming. My object is to analyze published articles systematically from 2012 to 2023 for 10 years related to global warming, especially in Africa, to investigate the source of greenhouse gas emission. Where the more greenhouse gas is emitted, or sources to know that is the main thing is to find the solution. If we know the source of greenhouse gas emission, we will find systematically to investigate how to stop it and to recommend sustainable mitigation in Africa. Assessment of the problem is that Africa faces several climate crises. Around
38.5 million USA dollars losses every year. Africa exposes global warming due to reliance of agriculture, natural resources, lack of technology. In Africa, the average temperature is rising more than 1.5 degrees Celsius. That is more hard to control. In meteorology, there are about 6 types of review, mostly for the students who are studying lab experiments. It needs a lot of time to find your own data. So not to lose time, you can do some review papers. The first one is critical review. This critical review papers needs more experience on the field of study. The main objective is to criticize the author or the result of the paper. If you have deep knowledge and if you find some paper related to your field, you can criticize that paper or the study area or the results by writing a review. This needs a little difficult. Some professors know. Especially writing review papers is very important to find more citation, more famous. If you write one paper, your own paper, maybe the people that are interested to read is fewer than review paper, because in review paper you can search many authors, search many related areas. So the first one is critical review. The second one is literature review. In literature review, you will search for your study area, keywords, authors, how they are connected to that study area. So the third one is systematical review. In systematical review, especially for PhD students, during defense time, they will ask why you are interested to this field. If you read this systematic review, you will answer easily. But like master student, maybe the title is given from the teacher or from your advisor. For PhD postdoc students, you have to reason out why you find the your title or your specific study area. So a systematic review is very important, and also meta-analysis is to use Prisma or including excluding method. Why you exclude other papers? If you go to on Google Chrome or other searching media, you can find 100 or million of papers related to your article or related to your study area. So you have to find a method to decrease the quality of, to find high quality of papers or to find specific area of the study area. Then the fifth one is narrative review. In narrative review, you can compare and contrast your some paper's result with your finding or another person finding, and you can write review paper. The other one is scoping review. This also to find which paper is published within the scope, within the interesting area. So these six types of reviews are very important, and we have to know which types of review is important for me, or I have to do this one. The second one is to find the data. For review paper, we will find our data or paper published from Google Chrome, Elsevier, or Scopus, Web of Science, EndNote, Mendeley, and text summaries. Most of the time, Google Chrome has many papers than other sources, because in Google Chrome there is a lot of papers that are not more important for the scientists. Maybe it is many papers are there. We will see on my staging area. A million of papers maybe give you Google in Google Scholar, because in Google Scholar, most of researchers or most of people put their finding or some papers on their research gate. So it will give from research gate that's not already published in scientific journal. So Google Chrome is not available for reviewing high quality review paper. How we export or how to we download the data from these sources. The first one is mainly it depends on the software that you are going to do. Most of the time, review papers are done by three softwares such as Lightspace, Voice Viewer, and Metrics. They need different types of data to run them and to find your results, such as links, country, which country is more steady or more published in your field area, which keyword is more important in the world, or which author is more famous in your study area. To find that one, you have to download the paper from those we listed in last slide. These are the two software that I use to study my review. The first one is Cytospace. In Cytospace, like in our data, we have to do correlation. If the correlation is met, you will go further to analyze your data. For Cytospace, you have to do modularity, Hilbert, and the density. If your density is near to 1, your data is good. You can go to further to analyzing. You can find, if that is met, you can find your, run your node. Your node may be country or affiliation, which university or which institution is more important in your study area. For example, in NUIST, in meteorology, if you want to do a study in meteorology, it is better to study in NUIST more than another university, like Hanjo, Yanjo, like that, because it is famous in meteorology. It has a rank in the world level. To find that one, you have to know your node and your system. And voice view is use the same node, but it needs Java. It needs Java analyzing. If your computer has no Java, it will not give you the result. For example, in voice view, I run some data. China is more higher. China has more stronger, and the US is the next in this data. So if you run your data, maybe some country become a big or has a link, and then you see which country, which author, which affiliation is more important for your study. And Metrics software also use Bob text. If you download your data from special Web of Science, if you download Web of Science, it is better because only the scientific papers are uploaded on Web of Science. They have high quality and importance for our findings. So it needs R software, and it's linked by R, and you can find the same figure. This is how we include exclude. In my study, my aim is to find greenhouse gas emission in Africa, or global warming in Africa. The paper published in the world level related to Africa, to find this one, I insert my keywords like this on Web of Science. It results about 62 papers. So I can't review 62 papers. For systematic review, only you can analyze or you can detect them less than 10 papers. If it is high, the result may be complex, and it is difficult to find the correlation of each author. So I use database, and the document I selected is only articles. When you type there, the Web of Science give you a lot of data, which is maybe review papers. You cannot review the review paper again. So you have to find only articles. Then if the paper is too high, you will only specify the time of study. If you find thousands of papers, it is so difficult to manage. So you specify the year, maybe top 5 years or new 5 years. Only relevant papers that used for your study. There is option there in the Web of Science. So if there is any another language, for me, it is difficult to analyze inside the paper in French or Arabic or in Chinese. So you have to specify in language place, select the language only in English. Or if you want to review the paper that is written by your language, you can specify the language. So how many papers are excluded by the language you will write there. And also use the software. Some data not run by another software. So you will specify the software and then select the slides and select the high rank papers. At the end of this selection method, I only select 6 papers out of 62 papers. Why I exclude systematically. And the next method, you will use Prisma. Prisma analysis currently it is very famous and very important. If you include your paper, this graph, many journals are interested to publish, especially Journal of Hindawi and Journal of Elsevier also very interested to publish like this. As I told you, I find on written on Web of Science, I find 62 papers. But on Google Chrome, there is about 12,800 papers. 12,800 papers is so big to manage. So there is many papers that are not scientifically improved. There is a lot of garbage in there. So it is better to find papers or Web of Sciences to run this systematic review. Or you can do the EndNote. For those, if you publish one paper which has 100 references, you can run that from 100 paper references that you use, which one is very important paper, which one you have to follow, which author is very interestful, which one is very influential for your future study. So EndNote and the Mendelin is very easy to do for this systematic review. So this including excluding method tells you how many papers are excluded every step. For I find 62 papers. After duplication, if you have sometimes the papers duplicated when uploaded different times. First, they upload without volume. After it get volume, they also upload. So when you stream, the duplicated one excluded. So in screening, the record screen 42, I excluded about review papers, letters, meetings, and editorial papers are there. And the full text, if you didn't find the full text of the paper, you cannot systematically review the paper. Some papers are very costly and closed. So if you have no option to download those papers, you can't systematically review. So you exclude that paper by reasoning outing it. And the result, these are some of it, and at the end, it left us about 8 papers to review. So in this, my result, it is not my result. The result is the other person or the other author's result. I compare them. I take the average. I have no risk to if it has some mistake. For I have no worry about the quality of the data because the data is done by other authors. You have to list their name when it's published, study of area, which country, and if you get some gap, you will put the gap of that paper. For example, if it is studied only in one country, the title is in Africa, but it is studied in one country or one region. That is the gap. You will put the gap of the study. So in this results, I find that the publication of in climate change or greenhouse gas emission articles are increasing within a steady year from 2012 to 2022, and also the citation is increasing. The number of articles published annually on greenhouse gas emission is less than 10 papers. If you are interested, if you search for your study area, if many papers are studied in your field, you will find such like this study. There is a gap. Within 56 or 57 countries, only 10 papers are published. So it is a gap. It is less paper. This paper may be for developing country for one department or for one affiliation. The average publication was about 4-year period, 4 papers per year, and Ethiopia and South Africa publish at least 1 paper per year. The highest country published in this area is Ethiopia and South Africa. Carbon dioxide emission and temperature correlation look like this. African temperature increases by 2 degrees centigrade, 1920 to 2022 in average. Most of the study says different results. The average says that 2 degrees centigrade increase by 2 degrees centigrade is so difficult, and it is out of world level. In the world level, it's planned to decrease to 1 degree centigrade, but our in Africa is so higher than the world. And South Africa is the first in greenhouse gas emission. So if some students are there in master's or PhD, you can study why it is higher in your country. In Africa, 3 to 4% world greenhouse gas emission is emitted, but our GDP is more equal to the world level. The impact is high. Even if the emission is low, the impact is too high relative to world level. These are the source of greenhouse gas that a lot of papers are mentioned. Land use and forest scale about the temperature, the greenhouse gases decrease to 0.66, while energy increases by 1.5% during the study periods. Agriculture and energy and the industry takes the highest emission of this carbon dioxide or greenhouse gas emission, while nitrous oxide and fluorine in Africa is increased more than 100 times, and methane also increases more than 90%. Also, the study covers that in river basin also greenhouse gas is emitted a lot. In world level, such as Amazon, takes the resilience of the world, and they are earning because of they decrease the greenhouse gas emission. But in Africa, such as Congo, rivers emitted a high carbon dioxide. Zambezi takes a highest emission of carbon dioxide, methane, and nitrous oxides in many studies. In other places, rivers and reservoirs are also emitting high carbon dioxide and methane according to these studies. Generally, when we compare the 2023 to versus to 1990, the power and the industry increases about 96%. 2023 to 2005, it increases 36%. When 2020 to about 2%, still the emission is increasing in other sector. So we have to find a solution for this increasing the greenhouse gas emissions. This to show how it is increasing every year. Carbon dioxide emission in Africa climbed after the millennium, especially. Also, the nitrous oxide and the methane emission significantly increased. These are some disasters that are created because of climate change in Africa. They are also increasing, especially from 2017 to 2009. How we mitigate? Every year, many places are greenhouse gas emission or global warming are increasing in Africa. These are some methods that suggested in many studies. More of studies in about 62 papers, they included this method to decrease the climate change or to decrease the carbon dioxide emission. They also give a value, which one is more important than the other. So it is high, medium, and high. So we can also include in this study. In summary, greenhouse gas emissions are affected by industrials, agricultures, constructions, and using of fertilizers. But in other side, forests, rivers, and some ponds are decreasing or extracting carbon dioxide from atmosphere. This the second graph shows that how climate change or global warming is related to carbon dioxide emission or water levels. In extreme climate affects hydrological drought that may increase or decrease the change in water table of the ground. Also, if the water table is decreased, the dissolved organic carbon in aquatic system also affected, and the dissolved organic carbon in water or in aquatic system starts to release carbon dioxide or methane that may increase the greenhouse gas emission. If the greenhouse gas emission is increased, the extreme temperature also affected or increased. In conclusion and the recommendations, the main source of greenhouse gas emission is agriculture and industrial operation. Between 1900 to 2022, greenhouse gas emission increased about 50%, and the temperature increased by 2%. Smart agroforestry could minimize carbon dioxide, nitrous oxide, and methane emission. In Paris Agreement, carbon dioxide emission should decrease by 1 degree centigrade. That should be controlled. Forestation and water supplies are promoting. These are some papers related to climate changes in my study. Thank you. If you have some questions, you are welcome.
Yes, okay, so now that we questions, okay? But we are going out of time. Please, if you have to ask questions, make it short and precise, okay? Okay, so do you have other questions? I think this is just a remark, actually, not really a solution, okay? Any questions?
Thank you for the question. I have just recently on one very good position. I usually rather get to in Africa from the validity to the Nile River your analysis. Thank you.
I want to discuss the meteorology. Because the more important thing is that in review, the meteorology is more important, especially for our study, than my results. As I told you, the result is not my result. The result is the result of authors or publishers that publish in that year. If they include, I will include. If not, not. But also maybe it is studied. Maybe it is out of my study year. I can touch in for 10 years. And also I prefer, there is a lot of method to exclude and include. If they are out of that method, even if they are very important, you will exclude. Sometimes you like the paper, but the methodology rejects it. If the methodology rejects the paper, you will reject it. Or you have to design your methodology. If you want to include all the paper published inside the within the study year, you will select number 2, literature review. If you select literature review, you will analyze all papers published related to that area or that for your keywords. But it's not measure the strengths. It's not touch you the result of the study areas results. Only measure which paper is more higher, which author is more important, which study area is more important for that analysis. But for me, I select about 8 papers. In that 8 papers, I collect the data which are related and which are matched. For example, one paper said that the carbon dioxide emission per year is 20. The other says 50 because of data gap. You will take the average and you will quote that authors inside your result because that result is not yours. So maybe your answer is your question is answered, and maybe for my brothers, it is
Uh, can you go to the slide containing the number of disaster due to climate change and figure, please? Yeah, like 17, maybe the number 17 slide.
Budget.
Yeah, chart, the bar chart.
Oh,
The one that show years of.
yes, this one.
No, the next, this. Next.
Next slide.
Next. The bar chart, showing the number of disaster. Yeah, this one. Here we can see that the number are increasing, right? At
Yeah.
first, but in 2010 and 2019, the number decreases. After reviewing all the articles, have you found that why this number are decreasing?
Yeah, for these types of review, if your interesting is to evaluate the paper, you will make the reason. If you are interesting to put the results and to compare, like this, you don't change anything on the publication. You put as it is. And if some papers are there which criticize these journals or these results, you will put some reasons on it. But for this one, they mention some, they mention some things related to technology. Some technologies are introduced after millennium. And also some researches are done because of that, some disasters are solved like that, but not specific things are there.
Thank you.
Can you please go to slide 9, slide number 9? Yeah, that particular slide.
This one?
Yeah, this. I would like to ask, is it part of your findings?
Because this one to show the software results, how it look like.
Well, you know that whenever you have to make a presentation, you make the presentation to suit the audience, okay? And with this, I would advise that in the next or subsequent presentations, you would modify this to suit your results. Okay, not to highlight, because there are so many countries which are not captured looking at your title. So for the benefit of this particular presentation, next time modify this to suit the topic.
It's okay. But my interest is to show the software how it is work.
Yeah, but for this particular,
I understand it. Yeah. Thank you. I'll take it. I'll correct. Good feedback.
I mean,
yeah. Thank you very much. Any questions? Okay. So I think I want to emphasize conflict on the abstract solutions. Okay. Feel free to submit your work, so that the good thing about this is you know share your work before you understand your work. So try and share your work that publish. Come here, present it to people, let them know what you have done, let them learn. That will help you to improve yourself and also to help people learn from you. Okay? Because some people don't have time to go and search your work, things like that. But when you came here, you show people what you have done. That really, for me, makes sense. I believe I'm not the only one. Almost all of you really makes sense. So please, we encourage you to submit your abstract, okay? We'll be doing this continuous non-stop, okay? Just send your work as part of the work we publish. Okay, so online, guys, if you have any questions, please, we have some few minutes for you guys before we call it a day. Any questions? Okay, we have one.
On the conclusion part of is it right to make a recommendation for future research?
Yeah. Yes.
So it's good to make recommendation for future research
Yeah, yeah.
during the conclusion of
Of
review
course.
cycle.
Well, yeah. When you use this systematic review and some graphs, you will see which part of study area is not filled and which where it is gap.
Yeah, those gaps. Okay.
Yeah.
The research gap
Then you
fund.
yeah, after that you will for instance in this graph it shows the cluster of the study here. If you your title related to this one, artificial intelligence is more studied. If you want to find gap, don't study on artificial intelligence. Find the gap to fill the gap. If you want to compete with more researchers, you can join them. Maybe you have to publish on high quality journal, because unless you prepare well, maybe they are satisfied. Your paper may be easily rejected. If you find the gap, like novel, the color shows the year. The red one shows the current year, and the blue one shows the it's forgotten one. So novel one, if you study on number 6 or novel one, the number it is higher number. The study area is there is so gap. There is a lot of gap. If you study there, your paper easily accepted, because there is a gap of study, a gap of paper, a gap of researchers. Also, the country, it shows if the dot is high, it has more papers. They are satisfied. If you go to America, don't study this area. They are already satisfied. Or you have to be more quality. Your paper should have more quality, unless it will easily rejected. So it shows to see the gap. In Africa also, I see the country, which country is more studied. You will plot on this one, then you will see Africa and South Africa and Ethiopia should high paper. And it shows the paper, how many paper, which inflation is published, who is published, when it's published. So you can understand easily.
Sorry, thank you very much. We have some 2 questions more for you from online. The first one is from Talim, who is asking why the impact of climate change pronounced even in region where emission of greenhouse gases is less.
I didn't understand.
And the question is like asking why issues of climate change is pronounced where the issues of the greenhouse gases is less. You know, in Africa, the greenhouse gases will emit less.
The more important thing that in Africa, the impact is high, but the emission is, compared to the world, it is low. The reason is that in our continent, the more emitted is methane. The methane emission is it is high risk than carbon dioxide, about 38 to 28 to 38 times. It is more hard, and it is quickly recycled more than carbon dioxide. Carbon dioxide is needed to recycle about 100 years to recycle by itself, but methane is recycled itself about 28 years. So it is hard to control. And also we have a lot of animals. Byproduct of animals in Africa is one source of greenhouse gas emission compared to other world. This is also one impact. And our agriculture byproduct is also the source of methane.
Thank you very much. I think you have answered the question. Last one is from Matthew. Is asking, based on your review, what are the research gaps not addressed in the previous studies concerning greenhouse gases emission over Africa. Like it's asking specifically those research gap that was not literally addressed.
Okay, I didn't include on this paper, but in this slide, but the carbon dioxide emission in greenhouse gas emission in Africa, the one gap is that data. There is no enough data to compare all in over whole Africa. Most of them, it is published in small region. So it is difficult to compare, especially in if we see we have a lot of rivers in Africa, but there are not more than 10 rivers are studied. So it needs, especially river basins in the Africans are source of greenhouse gas emission, but there is no that much studies, that much paper published in Africa. The second one is that our agricultural system. There is a little paper written or include the methane and the carbon dioxide from farmland and animal byproducts. In developed country, everything is registered and it is well known from agriculture, but in our area, it is no data is there. So in area that in agriculture and river basins have a gap. My study also, I selected river basin greenhouse gas emission. My study area is I selected because of this review, and I also have another review. Then I selected on that review on that gap to fulfill the research gap. The batteries law.
Okay, thank you very much. I believe Matthew, your question is answered. With this, I think we can end this. We want to say thank you for attending, okay? And thank you for your patience because we actually had about 19 minutes for what we have said, okay? I will try to, because we haven't started at 4, make us to, okay? We believe you understand. So maybe we can go for a group photo, the one that maybe you can just comport, we take a picture, then we go, okay? And I encourage those one who have interest to submit their abstract. Please try to do that, okay? Thank you very much. Just come. And you come out to the place of the group photo.